Or we're going to have some philosophy time?
No, this is a short lesson. We have 1 hour.
Okay, so vectors continue. So this is the last part of the topic of vectors that I want to talk about. And we want to change our perspective from geometry to algebra. It's very, by the way, it's very, very important so that we have the algebraic point of view of geometry. Yeah, so far when I talked about vector was a geometric object. Yes, it was an arrow. So it is a shape. But when we talk out in algebra, usually we have numbers. Okay, so we want to find the relation between these two concepts, and it makes life much simpler. This is something called analytic geometry. Okay, and I think this French philosopher Descartes, I think, invented this analytic geometry. So you have some ideas before about this, yes? So you know that point is also a geometric object, but I am sure that you have studied in your Grundschule that you can represent any point by 2 numbers. Yes, for example, of course, if you are working in plane, assume that you restrict yourself to be inside on the whiteboard, and then only 2, and then from geometric point of view, I can put a dot here and I say that this is a point. Of course, this is not the real point, because the real point is an abstract notion of this. If I put it under the microscope, it has dimensions. It has a length and it has a width, so it's not a real point, because the real point is something in your imagination. It should be dimensionless, okay? But this is, of course, something that we can imagine in our head. I cannot show that, okay, this is a point. This is a representation of a point. It's a good representation, because if I draw something like that, and I say this is a point, you will start laughing to me as yes. So it is not clear, yes? So it means that this is not a point, but this is not still a point. But at least it's a good representation of what we have in our brain as an abstract notion. Okay? So it means that if I want to talk about another point, okay, this is another point. But if I set up a coordinate system, what does it mean, a coordinate system? So, for example, let us start with 1 dimension first. Assume that I have this axis. There is an origin, there is a point that I consider to be origin, and then I have only degree of freedom. If I want to restrict myself to this line, I can just go to the right or to the left. This is just 1 degree of freedom, left or right. Okay? In a space, we have 3 degrees of freedom. Okay? Left and right, back and forth, up and down. Yes? These are the freedoms that we have in a space. But assume that you limit yourself to 1 dimension. And don't think that this is very artificial. No, for example, if you are driving in a straight road, even though you are still living in a 3-dimensional world, but you are actually following 1 road, and that is 1-dimensional object. Okay, so it means that even in reality, even though this is something abstract, it should be in your head, okay, but you can also think about some situations in our universe so that they are following 1 dimension. Okay, even the car itself is 3-dimensional, but if you want to understand the physics of that car, which is going with a uniform speed on a road, we can just assume it as a point which is moving in 1 direction. Okay, if I want to, now assume that I have a point on this line. Can I represent this point by a number? Assume that I want to give an address for this point. And I tell you that the points that I am talking about are restricted to be on this line. Yes? So you see that I can just simply measure the distance of this point to here. And for example, assume that this is 5. Then I would say that this point A, I assign a coordinate to point A. I would say that the number that I assign with A is +5. This +5 is enough for giving the address of this point on this line. Yes, when I say +5, +5 is a number, be careful. It is in the world of algebra. but this point is not in the world of algebra. It is in the world of geometry. But I find a connection between them. If I want to address this point, which is a geometric object, I tell you +5, then immediately you find this address, yes? If you have this convention that the origin is somewhere, for example, if you know that I am measuring everything with respect to this point, okay? So I need two things, a magnitude and a sign. This means that this is enough. If I give you +5, I give you a sign, I give you a magnitude, then immediately you find your address here, which is the point A. I can, for example, say that point B corresponds to -2. Then what does it mean? It means that this is a point. The distance of this point from the origin is 2 units, but it is in the opposite direction because of this negative sign. So, for example, you do something like this, and you find your address, and you are happy, yes? This is your point, for example. But so then instead of writing these symbols and things like that, usually you know that this is called the x-axis. This is convention. On the horizontal axis, we put x, and then we call it x sub a. It means that the x coordinate that I am assigning to this point A is 5. Here, if you want, you can write x sub b is equal to -2. It means that the x coordinate of this point is -2. And you understand what does it mean. So as far as you are concerned, by just one single number with its sign, I can find my address. Okay? But now assume that I have a point here. It is not enough to give one number as the address for this point. Yes? Because this point is not on this axis. But two axes are actually enough to give the address of that point. Yes? If you draw a vertical axis, by the way, it is not necessarily vertical, but let me just not to confuse you. Let me just draw what you know. So this is a vertical axis, and then you put the name of y. This is common in mathematics. The horizontal line, the horizontal axis is called the x-axis, and the vertical axis is called the y-axis. And then they should be perpendicular for any purposes that you need. And then if I want to give the address of this point C, you see that I cannot say x of C is equal to, for example, 4.5. This is not enough to reach to that address, yes? Because you don't know. When you say x of the point is 4.5, it means that this point is also has the xc equal to 4.5, but you have already studied this has also the same x, this also has the same x, this also has the same x, and etc. Okay, so it means that one number is not enough for finding that address, but two numbers is enough. Yes, if I, for example, if I give you this. For example, assume that this is, I don't know, 3 units, and then I will do this one, assume that this is, I don't know, 2.9 units. Then I can say that the address of this point corresponds to two numbers. One number is 3, and the other number is 2.9, yes? And then this is the convention again, that the first number is the x1. It could be the other way around, but this is the first convention that people made, and then we are following. So the first number refers to the x coordinate, the second number refers to the y coordinate. Okay, and we don't write it like this, we write it like this. We say that C has two numbers, 3 and 2.9 associated with that. So if you want to find the address of C, what you do, you start from your origin. You go 3 units on the horizontal direction, but in which direction? Because 3 is positive, you need to go in the positive direction. So you go 3 units here and you stop. And then after finishing that one, you need to go 2.9 units in the positive y direction. So I will start from here and go 2.9 units up, and I find my address. So it means that if I want to address a point on the plane, I need 2 numbers. Of course, you can also imagine if I want to address a point in a space, in this room, for example, 2 is not enough, yes? I need how many numbers? 3 numbers, yes? I need to give you the x coordinates. This is called the x coordinate. This is called the y coordinate. I also need to say how high is the point from the floor. So if I just give you the distance from that point and the distance from that point on this direction, it's not enough. There are many points with that property. I also need to give you the height. Yes? And this is easy to see that this is a 2-dimension. And then this is easy to see the 4th dimension. Imagine the 4th dimension. If you want to, if you have an appointment, 3 numbers is not enough, for example. You can say that, okay, you can come to this corner, and then the 3rd floor. So I go to that corner of the street, and then I go to the 3rd floor. But there's also another parameter involved. What is that? Time. So if you can go actually to the same building, to the same place, but assume that you have an appointment in 6 o'clock, but you are there in 4 o'clock. So the meeting will not happen. So it means that in this case, imagining the 4th dimension is not that hard. So 3 dimensions means 3 numbers, 4 dimensions means 4 numbers. And then what is the 5th dimension? I write another number there. So mathematically, it is easy to imagine dimensions. But when you want to realize them in physically, it becomes a little bit hard. Yes?
So a dimension doesn't have to be a spatial dimension in that.
No, so in mathematics, dimension is exactly the number of degrees of freedom that you need to fix so that an event occurs.
Okay.
That is called a dimension if you want to if you want to have an imagination. Yes, but we get used to think of dimensions geometrically. Even right now, we have 3 axes. We cannot imagine the 4 axis. Yes, but we were able to imagine that the 4 dimension can be time as simple as that. Because if I want to give you, if I want to have an appointment with you, I will give you not only my location. For my location, I need to tell you, I don't know, the position of my particle, the position of myself, and then the time. Okay, so if I add all of them for my position, I need to give you 3 numbers in principle. And for when, I need to give you another number. That is the dimension of time. So in principle, I have 4 dimensions, yes.
Can there be more than time, something else?
Yeah, of course, yes. According to many physical theories, I don't know, string theory, it hasn't been proven yet. It hasn't been confirmed experimentally. But that theory claims that there are 10 dimensions of a space and 1 dimension of time. But the dimensions of a space are so tiny curled that you cannot see them. And unfortunately, we couldn't actually make an experiment to confirm those extra dimensions.
Ah.
Just mathematically. You know, the technology hasn't reached to that point yet. Okay, so this is something that I want to mention. Of course, this I don't want to emphasize because this is something that you know. Do you know how to find the coordinates and points? Yes? Yeah. But now, let us go to our next object. Our object is not a point. Our object is extended, okay? Is a vector. Do you think, how do you understand this? I want to make a vector from geometry to algebra. I want to change the way that I think to a vector to an algebra. So I need to encode the information in any vector algebraically with numbers. So let me draw a vector here for you, but let me set up a coordinate system. Even I don't need to set up a coordinate system. So let me just draw this vector. Let me call it vector V. How do you think I can encode all the information in this vector with numbers? Let us review. Let us understand what I mean. What are the properties of the vector? There are 3 properties assigned to any vector. Yes?
Magnitude, slope, and direction.
Yeah, these are the only ones. So it means that when I draw a vector, you see all these 3 things, even if you don't care, but you can, if I ask you, you can find them. I can ask about this slope because you immediately realize there is a difference between this vector. Even if I draw exactly the same size, your eyes immediately recognize that these are different vectors, yes, because the slopes are different. So the slopes are different, so you do not recognize them as the same entity, yes? It might happen that I have the slopes the same, but the size is different. You immediately realize that they are not the same, okay? It might happen that everything is the same, the direction is not the same, yes? Immediately you realize this. So it means that if you want to represent this algebraically, how many numbers do you think I need to represent it? Can I represent a vector by single number?
No.
If the vector is actually somehow its size, then yes, I could just give you the size of the vector and I am done. But if I just give you the size of the vector, I am not done, because the slope is not addressed in one number. The direction is not addressed in that one number. Is that clear? Okay, so how many numbers do you think I need to address a vector?
Three.
No, so yeah, in principle, you okay. How do you say 3? Let us see.
One for every single attribute that they can have. Since vectors don't need a specific coordinate, they're independent of that, but you need to specify the direction, the slope.
Okay, it's a very, very nice argument. So you say that in principle I should give 3. Okay, how many?
4.
You would say 4. What is your idea? Why?
For every side of the arrow. You know, the tip of the arrow needs 2 numbers, and the other side needs the other 2.
2. Okay, so she is saying that I need 4. What? That's a very good question, Mari. It's a very idea, because you say that if you give me the 2 points, I can draw the vector. Yes. So for this point, 2 numbers. For this point, I need 2 numbers. Okay. But do you think that these numbers are independent of each other if the length of the vector is also given to you? Is that understandable? But that was a very good idea, because she's saying that if I want to draw a vector, you need to give me the initial point and the final point. And then if you say this is the initial and this is the final, I draw this arrow and put the tip of the arrow there, I am done. Is that clear? Because any vector has an initial point and a final point. Yes? Then I can find this vector. But this is not exactly correct. The reason is that if you give me 4 points, I can draw a vector, but I can just change the location of the vector, but the vector is not supposed to change. Do you understand? So if let me make this clear for you. So if you have this vector here, let me draw a coordinate system. You have a point here, you have a point here, I draw this vector. Okay? But now let me take this one and parallel transport it here, and I give you these 2 points. First of all, do you see that these 2 points have different coordinates than these 2 points?
Yes.
Because they are at different places, yes? But if I draw this vector, is this the same vector or not? From vector point of view, I told you that location is not associated with the vector at all. The slope is the same, the direction is the same, and the length is the same. So it means that if I give you 4 numbers, these 4 numbers is not exactly this vector, it's more than one vector. You understand what I mean? Because so these 2 vectors are the same, but these points are not exactly the same. This point is different from this point, is different from this point. So it means that I need to design a way so that if I do this with these 2 points, it gives me the same vector as this one. But that was a very good point. Yes?
This is the starting point that is supposed to be 0.
Yeah?
So then always goes from 0 to the 2 numbers.
That is a very good idea, but how many numbers then I need? 2. Because you are saying that always take the initial point here, and then I will give you the tip of the arrow.
Yes.
And then you connect this to that one, then I am done. So in principle, by 2 numbers, I am done. Because I would say that, because you are telling me that the location of the vector is irrelevant, so there is no difference between this vector and this vector parallel transport from here. So they are the same. Do you agree? This is by what we learn in vectors. And then for this vector, which is called the position vector, the vector drawn from the origin is called the position vector, only the tip of the arrow is important. And for this one, I need 2 numbers. So 2 is the answer. This is one way that was very good, thank you, seeing this problem. But another way, assume that you don't have any coordinate system. If you draw this vector, I can tell you that go horizontally, for example, 4 units, go horizontally 4 units, and then go vertically, for example, 3 units. So the information, all the information that I need in this vector is encoded in these 4 numbers. Yes. When I say 4 and 3, we have this contract between us. Okay. We agree that when I say 4 and 3 for a number, they are coordinates. But when I say 4 and 3 for a vector, it means that the start going 4 units horizontally and 3 units vertically. So that is your vector. So this vector is denoted by these 2 numbers, 3 and 4. Okay, so be careful about that. This 3 and 4 is different from this 3 and 4 that I use here. When I say my point C has coordinates 3 and 4, what do I mean? I mean that I go 3 units here, and then I will go 4 units here, and then this would be my point. Okay, so that is my point. But when I say my vector V is equal to 3 and 4, first of all, remember that this is the rule. We don't put equality for points, we put equality for vectors. When I say vector V is equal to 3 and 4, I can say that, okay, this 3 and 4 is the final point, and the original initial point always I take to be the origin, and then I will connect them and put the tip of the arrow at the end. So this 3 and 4 encodes all the information in this vector, including the length, the direction, and the slope. Is that understandable? But the interpretations are quite different. These are called coordinates. These are called components. These are the names. These are the difference between names. So these are called components. The x component and the y component. But these are called the x coordinates and the y coordinates of a point. I cannot say that this is the coordinate of a point on the vector. Okay? Because vector is not single point, it's an extended object. But how should you interpret the components versus these coordinates? When you say a vector has components 3 and 4, it means that you start from wherever you want. Of course, if you prefer, you can start from the origin, but it doesn't matter at all. You start from wherever you want, you go 3 units horizontally, and then 4 units vertically. So for example, if I want to draw this vector, I start from a point, I go 3 units horizontally. So let me make it clear. So 1 unit, 2 units, and 3 units. And after that, I go 4 units vertically, 1, 2, 3, and 4. And then I connect the initial point to the final point and draw my vector. Yes? So is that clear? And it doesn't matter where I start, because if I do the same process from here, if I draw it very precisely, I will get the same vector, even though the location is changed. But the location is not important. Assume that I take this point. I go 1 unit, 2 units, 3 units to the right, and then I go 1 unit, 2, 3, and 4 up. And then if I connect these 2 points, if I do this very precisely, you will see that this thing that I get here is parallel to this one, has the same direction, and has the same slope. So these 2 vectors are exactly the same. So that is what we wanted to do, okay? So from now on, in plane, only your lesson is in geometry in plane, not in a space. In a space, again, for vectors, I need 3 numbers. But forget about it. It's exactly what we need here in this lesson. So from now on, you see, a vector V has 2 components. Vector V is equal to A and B. It means go A units horizontally, B units vertically. In which direction? Depending to the sign of these numbers. If A is positive, go to the right. If A is negative, go to the left. If B is positive, go up. If B is negative, go down. Yes? For example, let us draw this vector. Vector V is equal to -2, -4. -2 plus 4, for example. I want to draw this vector, construct this vector. So I will have my coordinate system. It doesn't matter where you start. If you want to, you can start from here, but that is not an obligation. I can start from here. Let me start from here, you see. Make it clear. So I go 2 units horizontally, but in the opposite direction of the x-axis because it is negative. So I start from here, 1 unit, 2 units here, and then I go 4 units upward. Yes, so it becomes this one and then 1 more. So sorry. So 1, 2, 3, 4, something like this. Yes, so 1 unit, 2, 3, and 4. So 2 minus 2 and 4. So I reach to this point. It's too long, yes. So I started from any point that I like. I go 2 units to the left and 4 units up, and then I connect the initial point to the final point. This is your vector v. And it doesn't matter if you draw it from this point, or you draw it from this point, or you draw it from any other point. Your direction, your size, and your direction are not changed. Is that clear? So for us, usually, even though pictures are very good for us to visualize the concepts, but working with numbers is easier. Yes. So if I tell you that give me a vector, it is easier to write 2 numbers instead of drawing a shape. Yes, usually. So that is the benefit of it. But of course, this becomes useless if I cannot do any operations with this kind of objects. So the first thing that we learn is that if I want to add 2 vectors, vector v1 and vector v2, we know how to do it geometrically. Yes, we have to draw shapes. I need to draw the first vector and parallel transport the second vector from the tip of the arrow and then add a new arrow. Add them and find a new arrow. But what do you think would be a translation between this geometric picture and this algebraic picture? Okay, so let me tell you once more. When you see this vector, what does it mean? It means go to 2 units to the left, 4 units up. Okay, now let me draw 2 vectors. So for example, assume that this is a vector, that is another vector. Okay, you know that if I add these 2 vectors, v1 and v2, geometrically, it becomes this vector. Okay, now assume that this vector v1, is, for example, 3 and 3. Okay, what does this vector mean? What does this vector mean here? It means that by looking at these numbers, you see that vector v1 means, is someone there? So when you say v1 is 3 and 3, what does it mean? It means that by looking at these numbers, you realize what the vector is. It tells you go 3 units to the right, 3 units up. And let me tell you, for example, this vector. Can you give me reasonable numbers for this vector? Just guess, because this is not exact. For exact things, I have to draw this in the grid paper. But do you think the y component is positive or negative for this vector? This vector takes you to right or left, this vector?
Right.
It takes you to right. It takes you down or up? Down, yes, it goes down. So it means that this one should be positive. For example, I don't know how much is that. Let me try to convince you somehow. So here, I am telling you 3, 3, yes? It means that you start from here, go 3 units to the right and 3 units up, for example. And then let me tell you, for example, this one is 2 units to the right and minus 2 units to the left. So if I ask you what is this vector doing for you, you would say that it will take me 3 units to the right and 3 units up. If I ask you what this vector is doing for you, you would say that this will take me 2 units to the right and 2 units down. Okay, now this vector, what is the name of this vector? Can you tell me? What is the name of this vector?
May I say?
Yes?
v1 vector plus v2 vector.
Exactly. And now I am asking you the same question. what is the role of this vector? How much do you think that this vector will take you to the right? This new vector. Is that clear? It is the sum of these two. Is that clear? Because this vector will take me 3 units to the right. So from here to here is 3 units, because this is supposed to take me 3 units to the right. Okay? This vector will start from here and takes me 2 units to the right. So if I ask you how much is this, what is your answer?
3 units.
Yes, the length that I have been shifted to the right by this vector, 3 units, and this one is 2 units. And then if I say how much is from here to here, it's clear, it is 3 plus 2, it's 5. Yes? So if I ask you how much this vector is moving me to the right finally, it is clear that this is 3 plus 2. Yes? And then, do you think that this vector will take me up or down, this new vector? Up. But how much?
1.
1. Is that clear? So how did you got this? You said that I add these 2 numbers as well. So isn't it simple?
Yeah.
If you want to add 2 vectors, just add this number to that number, this number to that number. You don't need to draw any pictures at all. And this is the power in analytic geometry. This is geometry again, because we are talking about vectors. But we have changed our perspective how to see the same problem from algebraic point of view. Is that clear? So it is very, very simple. From now on, you know what is the meaning of a vector, but I coded the information in any vector on plane in 2 numbers. And then I realized if I stick to that rule, the numbers that are for this are simply the sum of these 2 numbers and the sum of these 2 numbers. So simple, yes? So I would say that if I give you the vector v1 to be a1 and b1, and if I give you the same vector v2 to be a2 and b2, if I ask you what is the sum of these 2 vectors, you don't need to draw any picture at all. What you need to do is to add the x components, the first components, a1 plus a2, and then you can simply add the second components, b1 plus b2. Is that clear? So it is very simple. You know, it is. You see, it's much simpler than drawing a shape or a picture. But so I want you to understand the connection. I don't want you to think that this is a rule. This is not a new rule. And this is what I want you to understand. I knew about vectors. I try to motivate you that any information in any vector on plane can be encoded in 2 numbers if you interpret those numbers in the way that I told you. If you accept this one, then automatically you understand that if I want to add 2 vectors, I have to do this according to what I told you here. Is that clear? Yes or no?
Yes.
Okay. And then the similar idea will work for subtraction, but let me subtraction comes first. So what is the next operation that we need to know? The one thing that I want you to know is the length of a vector. If I give you a vector geometrically and I ask you what is the magnitude of the vector, you have to measure it. It means that you need to take your ruler and measure the length and say that that is the number. But now, algebraically, we can actually calculate the length exactly. How? For example, I tell you that a vector v has these 2 components, a and b. My question is that, what is the size, what is the magnitude of this v? How should I calculate that? Yes? Pythagoras theorem. How? Can you motivate me? For example, I have a vector here. Okay, now you tell me, how do you motivate that Pythagoras, how do you think that Pythagoras will be important?
Well, if you use the a and b.
So what is the meaning of this a? For example, assume that a is positive. In this direction, is a positive or negative for this vector?
Positive.
Because it is taking me to the right. Is b positive or negative for this vector? Again, because it takes me up. Yes? Okay, but if I ask you, if I draw a vertical line from here and a horizontal line from here, now I ask you, by looking to this vector and this information, can you tell me how much is that? You? A. Because it is taking me a units to the right. So this length should be a. Yes? And if I ask you what is this length, B. And then because this is horizontal and this is vertical, this is clear that this angle should be 90 degrees. And now what you see here is a right angle triangle. And then I can use the Pythagoras theorem. So what is my goal? My goal is to measure this length. But I would say that the length of vector V, which is this one, to the power of 2, is equal to this length to the power of 2 plus this length to the power of 2. Agree? Is that understandable? But my goal is to find this question mark. I need to get rid of these two. What should I do? I need to take a square root from both sides, but I told you in algebra, you have to put plus and minus. But of course, in the context of geometry, the size cannot be negative, yes? So it means that from algebraic point of view, there are two answers. But one of the answers is not acceptable because the length cannot be negative. Because of that, you clean this, and this is your formula. As simple as that. You see, nothing is being measured anymore. Everything is being precisely calculated. Yes? 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 Is that clear? So that's also the length. Another operation, I want to give you an example so that you can feel why this is correct. Another operation that we learned. Okay, by the way, let me test your understanding. Do you remember we also had the zero vector? Okay, and I told you that every vector corresponds to two numbers in this way of interpretation. So can you tell me what are the components of the zero vector? Everyone, just everyone.
0 and 0.
0 and 0. Why? Because this zero vector doesn't have any length. How much it will take me to the right?
0.
Nothing, 0. How much it will take me up?
0.
0. So this is 0. So remember this, let me write this one here. So the zero vector means 0 and 0. Be careful, be careful. If I write O 0 and 0, it is different from saying that vector 0 is 0 and 0. Yes? What does this mean? Yes?
It means the point origo.
Origo, yes, origin. Yes? But this means the zero vector. Is there any location for this zero vector?
No.
So here, be careful. If I want to draw this one, if I want to show this point, there is only this point that I have to show for this one, nothing else. But for the vector 0, can I say this is vector 0?
Yes.
Yes. Can I say this is vector 0?
Yes.
Yes, because there is no location attached to the vector. Understand these differences, yes? Okay, so that is also something. Another operation that we want to do you remember, is the negative of a vector. So can you understand, based on this geometric picture, what would be the components of the opposite vector? So if I have a vector V with components A and B, what do you think would be minus V? For example, assume that this is your vector A and B. It means that this vector takes me A units to the right, B units up. For example, in this picture. What do you expect for minus V to do for you?
Minus A minus B.
Is that understandable? Because if this is V, if I ask you what is minus V, you already know what is minus V. Do you see? This is minus V. Yes? If vector V takes me A units to the right, this vector will take me A units to the left. Is that clear? And if this vector takes me B units up, this vector will take me B units down. So if this vector is A and B, minus V is what? Minus A and B. Isn't it simple? Algebra is much simpler. So if you want to multiply, if you have a negative sign, just put the negative sign for the components, as simple as that. So it's very, very powerful. Be careful about this. Okay, another operation that we learned. What was that? We learned how to add two vectors. We also learned how to subtract two vectors. Yes. After we learned the opposite of a vector. Do you remember how did I define it for you? Do you remember how I told you to subtract two vectors? in very beginning, not drawing a picture. Even drawing the picture, how did we draw the picture? Yes?
V1 plus
Negative.
the negative.
Exactly. So do you remember when we learned this before? What I want you to understand, which is a little bit missing in the book, is I want you to understand we are not doing something new at all. We are translating what we learned in geometry into algebra. We are not something new, but we want to understand how this will go. So this is the definition for subtraction of two vectors we learned before. But now tell me, if I have V1 to be A1 and B1, if I have V2 to be A2 and B2, yes, how should I subtract them? How should I subtract them? I need to write V1 plus minus V2 according to the rule that I learned before. But I know what is minus V2. We just learned. What is minus V2? It's minus A2 minus B2. Agree? And then I learned how to add them. If I want to add two vectors, add the components correspondingly. The first components should be added together. The second component should be added together, yes? So now I want to make this vector. I need to add the components of this vector with the components of this vector. Okay, how should I add them? I need to add A1 to the component of this one. And I need to add the component of this. Don't close the door, please. B1, don't close the door. Minus B2. Okay, and then nobody writes A1 minus A2 plus minus A2. People write it simply A1 minus A2 and B1 minus B2. Agree? Okay, so now another rule. So let me write all the rules in one place, okay, so that you are not confused. This is the first rule. This is the second for finding the magnitude of a vector. Let me also write this vector 0 here, is 0 and 0. And let me take this away. And now we learn that if I have a vector V equals to A and B, if I ask you what is the negative of V, it's very simple. You just put a minus sign here and there. So let me give them names, number 1, number 2, number 3, number 4. And now this is number 5. So number 5 tells me that if I have V1 to be A1 and B1, and if I have V2 to be A2 and B2, what can I do? I can write for V1 minus V2, I can simply subtract the components. A1 minus A2, B1 minus B2. Yes? And there is also another operation left. What was that? Yes?
Multiplying a vector by a number.
By a number. So if you can also understand that one, then we are done. Now let us see. For example, this is a little bit tricky. Yeah. It is not that easy. You need a little bit more geometry. Might be you can use similarity as well, but it needs some work to make sure that everything works fine. So for example, let me give you this vector V. Let me keep it as A and B. Assume that A is positive, B is positive. Okay, now let us concentrate on the vector. Let me make it a little bit of space here. So this is vector A. This is vector, let me write here. Vector V is A and B. Now let me multiply this vector by 2, for example. Okay, by 2. So what will happen? This vector V, 2V is parallel to this vector. It's pointing to the same direction because this is positive. And then the length should be 2 times larger, yes? So what would be the 2V? 2V is from here again up to this point. So this is 1V, this is 2V. So this black one is 2V. Now let us, for example, draw a horizontal line and draw a vertical line from here. And also draw a vertical line from here. If I ask you how much is this, what is your answer? It's A, because this is A, it takes me A units to the right. Okay, now my question is that how much 2V will take me to the right?
2A.
Is that understandable? It is 2a, yes? Why is the case? Why is that the case? If you really want to do it rigorously, first of all, it is not that hard to guess. This is also 2 times larger. But what is the real reason for that? The reason is that these 2 triangles are similar. This small one and this bigger one are similar. Why they are similar? Why these 2 triangles? You see, this is small triangle here, and then the bigger one should be similar. Why? Yes?
They have 2 90-degree angles.
Yes, so this angle is 90, this angle is 90, the other one? In common, exactly. Thank you very much. This is very clear. So this 2 angles of this triangle is equal to 2 angles of this bigger one, so they are similar. When they are similar, what does it mean? Assume that you still don't know what this is, but you know the scaling factor, yes? Why? Because you would say that the length of A over X is equal to the length of this over this. The length of V over the length of 2V. First of all, is that understandable what I have written here?
Yes.
Okay, so here I drew this picture and I confirmed that these 2 triangles are similar. When they are similar, it means that the ratio of corresponding sides is equal. So this smaller one divided by this bigger one should be equal to this one divided by that one. Should also be equal to this one divided by that one. But let us keep it for the time being like that. Okay, now can you tell me how much is this one? The size of vector V divided by the size of vector 2V. What is that one? Everyone. 1 over 2. Do you agree this is 2 times larger than this one? So this is 1 over 2. So this means that A over X is 1 over 2. So this means that X times 1 is equal to 2 times A. So your prediction was actually confirmed. You actually instinctively said that this is 2A, and this calculation confirms that. So you are right. If I multiply the vector by 2, it will take me 2 times more to the right and 2 times more upwards. Yes. So can you tell me now what should I write in front of this if I want to write the components? 2A
plus 2B.
Not plus.
No, 2A.
And 2B. Yes. 2A and 2. And this is not only for 2, it works for all possible numbers. If you want, we need to draw some pictures for you and explore this relation. Okay? So now, if everything here is clear, I would write it as number 6. If V is a vector, A and B, and alpha is a number, so let me clean this, and alpha is a number, alpha is a real number, any number that you like, then if I ask you multiply your vector by alpha, it is not drawing any shapes. It is much simpler than that. You just multiply the first component by alpha. You also multiply the second component by alpha. And you see that we didn't learn anything more. These are the only operations that we learned about vectors. And they are very, very simple now. If you, first of all, from now on, you have two pictures. One geometric picture, one algebraic picture. In geometric picture, a vector is an arrow, and directed arrow. In algebraic picture, a vector is 2 numbers. In order, the order is important. You're not allowed to interchange them because it becomes another vector. How do you interpret these numbers for that vector? It means that your vector will actually translate you horizontally according to this number, translate you vertically according to that number. If the number here is positive, you go to the right. If the number is negative, you go to the left. And if this number is positive, you go up. If the number is negative, you go down. This is very important to understand. As soon as you understand this, the rules for adding vectors, finding the magnitude of the vector, the zero vector, opposite of the vector, subtraction, multiplying vector by a number is extremely simple. If you want to add them, just add the components.
Do you have another piece of paper?
Pardon?
Do you have another piece of paper?
Let me see if I can do it now. Oh, sorry, I just did. Are you writing in paper? You could write in the answers in the paper. Okay, you can have this one as well. There are enough space to write them now. You don't need to transfer your figures from there to here. Okay, so I forgot to say that. Okay, so if I have a vector, I want to add them, just add component-wise. Let me just do this one immediately. If I want to subtract them component-wise, yes? If you want to multiply by a number, multiply component-wise. It's very simple. And now, if I want to measure the length, not measure, to calculate the exact value of the length, you can remember this formula, which is coming from the Pythagoras theorem. It is not something new that we are inventing new mathematics. And if I ask you what is the zero vector, the zero vector is a vector with 2 zeros. Yes? Is that clear? So it is much simpler. For example, let me give you an example and then we are done. So finally, I think these vectors are done more or less in a reasonably good way. Okay, so, but of course, remember that this is the vector in plane. Yes, so it means that the vectors that I am working, all of them lie on the same plane. I can't have a vector in a space. Then I need 3 numbers. But if you understand this, the idea would be quite similar exactly there. So this is a very important example I want you to learn, okay? So, example. Another point that I want to emphasize. When you write vectors, you have to put this equality. When you write points, some books also put equality for points, but according to your book, when you say a point A with coordinates 2 and -3, according to the book, don't put this equality. Just write A with these coordinates, okay? But for the vector, it is essential. In any other books, they also put equality. You have to remember, these are equality. These are called coordinates. These are called components. So differentiate these words. Okay, so this is the final example for this very long chapter, vectors in geometry. So let V1 be equal to, say, 5 and -2, and V2 be equal to, by the way, if you don't mind, let me change the letters. Don't think that always I have to use this. Let me write this V and the other one U. -3 and 5. So these 2 vectors are given. So let me ask you, how do you interpret these numbers if someone asks you? You would say that this is a vector, so it is an arrow, but that arrow is drawn in a way that if I look at the arrow, I see that I am being translated 5 units to the right and 2 units down, and the same idea here. Calculate the exact value. Because now we have algebra, we can use the power of algebra. We don't need to take our ruler to measure something. Calculate the length of 2v minus 5u. Exactly. So this is a very important example. I want you to know about that, and then we are done. I want to wait for you. Don't calculate it. Do you want time? I can give you 2 or 3 minutes because we need to finalize everything before the lesson ends. Yes, do you want to talk about the method? So what do you do if you want to solve this problem? So you see that whenever you want to find the length of a vector, you need to have its components. If you have the components, then you can put them in this formula, you find the length of that vector. So I give you two vectors and I ask about the length of another vector. I have seen some students calculate the length of this one, the length of this one, and multiply the length of this by 2, multiply the length of this by 5, and subtract them or add them. This is totally wrong. Is that understandable? So you see, the question mark is this, the length of 2v minus 5u. If some of you, I want you to take a lesson from your own mistake. If you are thinking that I can find the length of this one and multiply it by 2 because of these two, and then find the length of this one and multiply it by 5, subtract them, then write the answer, that is not correct. If you think in this way, you are thinking that this is equal to this. Hopefully, you know that this is not correct. So you are not allowed to do this. The first thing that you have to do is to find the component of this vector in total. So what should I do? So if I want to answer this question, I would be a little bit patient. I would write 2v minus 5u is equal to. What is 2v? I multiply the components by 2, it becomes 10 and minus 4. Yes? And then I have negative, and I multiply 5 by my vector u. I know how to do that. I multiply these numbers by 5, which becomes minus 15 minus 25. Is that understandable? If I ask you what is this one, you would say this one is equal to that. If I ask you what is this one, you would say this one is equal to this. But now you see that I want to subtract these two vectors. Okay, so what should I do? I would write 10 minus 15, which is 25. And then I will have minus 4 minus 25, which is minus 29. Is that understandable? This number you have to get. After you are done, then you are allowed to, and you can answer the question mark. The question mark is the length of this vector. But this is very simple, because if someone asks you what are the components of this vector, you can say 25 and minus 29. And then I have a formula for the length of that vector. So then this becomes square root of 25 to the 2 plus minus 29 to the 2. And then you have to calculate this using a calculator, but I have asked you to put exact value, so you shouldn't take the square root sign because it will give you a lot of decimal places. If I remember this correctly, this is 625, but can you help me? What is 21 9 to the 2? What is that? 849. 1, yes? And then can you please add them? It becomes how much? So 14 and then 66, yes? But I don't think this is a complete square. So if you put this in your calculator and you get a lot of decimal places, just keep it like this. Because I have asked you exactly. So this is length units. So you need to write this in front. The question mark is this number, length units. Yes? Is that clear? Yeah. Okay, there's one small part that I need to finalize, and that is if I give you 2 points. Let me ask you here. I give you a point A with coordinates, say, for example, I don't know, 2 and 3, for example. And I give you another point here, B, with coordinates, say, for example, from here to here is 5. And then from here to here is 4. So these are not vectors, these are points. But I can make a vector out of these 2 points. This one, for example. Now, can you tell me what are, if I ask you what are the coordinates of A, what is the answer? 2 and 3. These are coordinates. If I ask you what are the coordinates of B, you would say 5 and 4, for example. Now, if I ask you what are the components of vector AB, what are these components? Can you see and read it from the picture? So how much I go to the right? 3 units. How did you calculate it? You calculate the difference between these 2. And then how much I go up? 1 unit. You calculated the difference. So it is easy to answer this question here. What is the answer? The answer is 3 units to the right and 1 unit up. This is my vector AB. So can you guess what is the general rule from finding a vector out of the coordinates of 2 points? If I give you a point A with, say, coordinates x1 and y1, and I give you another point with coordinates x2 and y2. Be careful, don't get confused. The interpretation of coordinates is different from the interpretation of components. Coordinates are for points, components are for vectors. If I have this, so this is the number 7 formula that I am adding here. Okay, now can you tell me if someone asks me about the components of this vector, how do you do that? Yes?
Subtract the components of B with the components of A.
Yes, which one should come first for the final point? Be careful. The final point minus the initial point. Okay, so these are the final points and initial points. So if I give you 2 points, I will solve 1 single or 2 single examples next time, and then I will go to the next topic, which is a very important topic of functions, okay, from next week. And then we know that the school is closed, so everything will be online, okay? So there is no time, I will give you an example only of this number 7. And these 7 rules are the only ones that you need to add on your previous knowledge around vectors. This is the algebraic way of investigating vectors. Any questions?
No.
Okay, thank you very much and have a nice weekend. You can show yourself once more.